So I think we can start. Good afternoon, everyone. Thank you for joining us today. So, my name is Ilania Carola, and I'm happy to be your host today for this webinar. We have a very special guest with us today, Giovanni Solito, and an extra one, Nikkei Ace, both senior product manager for u-blox. Today, we will explore the powerful combination of cloud-based positioning and LoRaWAN technology through our Cicerone board, which integrates our LoRaWAN module with a GNSS solution from our partner u-blox. We will also go through real-life applications from our clients, and we will focus on how the power constraining capabilities of our board have helped them achieve energy autonomy. So let's dive in and discover the possibility of the Cicerone board. So today we will understand the demand of ultra low power devices. So what is the reason behind the growing need of the development of sensors that are low power and for that long lasting? Then we will go on and we will also speak about how CloudLocate complements LoRaWAN for power constraint applications. Then we will move forward to some example of real life applications. And we will end with Giovanni and Nick telling us more about the MAX-M10S and the CloudLocate, and how they enable energy autonomy for IoT asset tracking. If you have any question during the webinar, please address them to info@movex.it, and we will reply as soon as possible. So let's dive in. Okay, so let's understand together why is there such an increasing demand on developing low power and long-lasting sensors. In today's data-driven world, IoT is revolutioning industries worldwide. However, the success of the IoT application is strictly linked on the availability of low-power sensors that can continuously collect and transmit data without draining battery life or requiring frequent recharging. Some of the benefits of low-power sensors are extended device lifespan. Low power sensors minimize energy consumption, enabling devices to operate for extended period without battery replacement, reducing the maintenance cost and environmental impact. Wide range deployment. In fact, low power sensor can be deployed in remote and challenging locations without the need for frequent power access, expanding the reach of IoT applications. Also, real-time data collecting, continuously data transmission from low-power sensors, ensure real-time insight and timely response, enabling proactive decision-making and efficient operations. So, LoRaWAN and CloudLocate. Let's explore how LoRaWAN and CloudLocate can work together to provide a seamless solution for low power, wide area connectivity and precise locationing for IoT devices. So we can make making this solution an ideal for tracking applications. So from one side we have LoRaWAN that enables long-range, low-power communication for IoT devices. It's well suited for application where devices need to transmit data over vast instances while consuming minimum of power. On the other hand, we have u-blox CloudLocate that enables cloud-based position service and complements LoRaWAN by providing matter-level location accuracy for IoT devices, utilizing advanced algorithm and data analytics to enable location precision. So why that's a perfect that is a perfect combination. So imagine that you have from one hand the LoRaWAN's low power connectivity that helps the GNSS to power save, and on the other hand you have the CloudLocate precise location capabilities. Together, they enable real-time asset tracking, improve geofencing, and optimize the fleet management, not only making operations smarter and more efficient, but also consuming the minimum. Giovanni and Nick here will go in deep on how LoRaWAN and CloudLocate can benefit can be a benefit for tracking application just after the real-time application from our clients. So we have the first use case that is an animal tracking and vital parameters nearby wind turbines. So the problem here was to check was one of our clients that is a renewable energy company faced here a crucial challenge. They wanted to study the impact of wind turbines on nearby wildlife and ensuring their safety. They wanted to compare the behavior and vital parameters of a group of animals that inhabits the area surrounding wind turbines with those in a nearby zone without turbines to understand the effect of the turbine on the habits and well-being of these animals. The solution here was our Cicerone board. In fact, our Cicerone board provides an ideal solution for this challenge because it is a Arduino MKR compatible and integrates also the u-blox MAX-M10S GNSS module. So our clients could track the movement of animals in both the turbine zone and the control zone. Combining the Cicerone board with appropriate sensors, they were able to create an easy and fast way, a prototype of a device that collect vital parameter such as temperature from both locations. This data was then wirelessly transmitted through the LoRaWAN network to a central monitoring system. By comparing the data from both zones, our clients gain valuable insight into the impact of wind turbines on wildlife behavior and vital parameters. These allow them to take appropriate measure to ensure the safety and well-being of the animals. So here it is okay, so use case number 2. So here it goes. The use case number 2 that we want to speak today, it's a smart beans management system. One of our clients faced the ongoing challenge to optimize waste collection and reducing operation costs. The problem of our customer here was the lack of visibility into waste bin fill levels. This led to an inefficient waste collection routes and an overflowing bins, and also unnecessary costs. Also in this case, the solution was the Cicerone board. Our Cicerone board provides an effective solution for prototyping devices for smart waste management. By integrating our Cicerone board with external sensor, our clients could monitor the fill levels of waste bins in real time. And the u-blox MAX-M10S GNSS module enable here to an accurate location tracking of each bins. Then the data transmitted through the LoRaWAN network allowed our client to optimize the waste collection routes, reducing unnecessary pickups and ensuring that the bins were emptied at the right time. This resulted in a significant cost saving and improved also the efficiency in waste management operations. In conclusion, to sum up, our Cicerone board with its integration with the u-blox MAX-M10S GNSS module has proven to be a versatile solution across various industries. And today we explored two of the compelling use case where our clients successfully addressed the challenge with the help of our board. From animal tracking near wind turbines to smart waste management, the Cicerone board demonstrated to be an effective and viable solution. So now I would like to leave the floor to our customers, so to our guests, Giovanni and Nick. Who will tell more about the MAX M10S and also the CloudLocate. So Giovanni, if you
thanks, Ilenia. Let me share. Okay, sure. So hello everyone. I hope you can see my screen, and I'm very glad to be here with you today our section will be made up of 3 small sections. One is to present the hardware, the M10. This is the latest generation of our GNSS. We have then CloudLocate, the service that is oriented to save energy. And finally, we have a presentation about our LoRa platform, our communication platform. But let's get started with the hardware. And yeah, M10 is the latest generation of our standard precision GNSS. And despite the very low consumption, there is no really compromise on performances. It supports 4 concurrent GNSS constellation, GPS, GLONASS, Beidou, and Galileo, and include also advanced spoofing and jamming detection. It really provides outstanding performance, even in with small antennas. And the reason is that we have a T6 oscillator for best accuracy, an embedded LNA for best sensitivity, and an embedded an LTE band 13-notch filter against RF interference. Now, let's talk a bit about form factor. We have a form factor for every situation. Well, M10, the MAX-M10, the one that you see here, okay, is a small form factor, just 10 by 10, let's say, but it's not the only one. We have MIA. You see, this one is just 20 millimeters square. It includes everything and is really a compelling solution for many wearable or where you have really you need a really small form factor. We have a complete solution that includes also the antenna, the SAM-M10, and finally also our chip that, as you see, is very close to the MIA form factor. Now that you have an overview of our latest generation of GNSS, let's move to CloudLocate. So this solution or this service has been designed with having in mind the reduction as much as possible of the energy consumption. So what we can achieve is a 90% reduction of energy consumption of the GNSS. And here there are the boundaries, or which is the good use case for CloudLocate. So whenever you need the location in the cloud, and most of the application, as we have seen in the latest year, really need just the location in the cloud. I would say 95%. Large power autonomy. I mean, if you're looking at this LoRa technology, it means that you really are looking to optimize the energy of your device. So CloudLocate can contribute on the overall energy budget. Few positions update per day, what we call sporadic tracking. It can be few times per day, 10, 24 times per day. It really depends, but this is more or less the range. And a reasonable position accuracy. So we are in the range of 10 meters accuracy. I think it's many applications and presented, well, all the applications presented by Elenia before me and also the one that I'm going to show right now are essential in this use case. Container tracking, livestock tracking, industrial tool, and small asset parser really are needs a position on the cloud again, and don't need continuous or cyclic tracking. So CloudLocate is a very good option. But how it works, let's see in action. It's not a demo, but it shows step by step how it works. So starting point is your device, of course, your LoRa network, and the service, and your application enterprise. So these are the stakeholders of the game. Now, first of all, the starting point is your GNSS that is switched off because you have to save energy. So you switch on the GNSS because you need a position, and you perform a cold start. And you know that when you perform a cold start, if you don't have aiding services, it takes some time. It takes at least 30 seconds, the GNSS, to converge to a solution. So it's a really waste of energy. So with CloudLocate, you don't need to wait so much time. You just need to keep the receiver switched on for a few seconds, let's say 3, 4 in average. And after that, you can switch off immediately the GNSS. What happens in this time? Well, the GNSS generates a raw measurement that is nothing more than a snapshot of the satellite. So which are the visible satellite and which is the signal, more or less. There are some information in a very compact format. It can be 12, 20, or 50 bytes. So it's really adapted to a LoRa network. And then immediately after that, you can switch off the GNSS. So again, just a few seconds of energy consumption or on time of the receiver. This message can be then sent over the network where we have a cloud engine that calculates the position based on this raw measurement. And that's all. So the position can be sent to your enterprise or can be fetched. There are multiple ways to access to this position. Again, what I want to point out is that you don't need any aiding service. That is the traditional way to shorten the time to first fix. In this case, you don't need that. And indeed, using LoRa is really difficult to use aiding service. And this is, again, just to point out that CloudLocate can be used with any connectivity, but the major benefit is really on LoRa or on satellite. But really, LoRa is really a good match, a very, very good match. I hand over now to Nick. Sorry, I forgot.
Thank you, Giovanni, and hello everyone from myself as well. So I just want to spend the last few minutes here just talking about a complementary service that u-blox offers called MQTT Here. MQTT Here is part of our communication as a service suite of products and is geared up for use with LoRaWAN. It provides a simplified LoRaWAN rollout with fully managed LoRaWAN network server components. So your join server, your network server, and a gateway bridge are all provided as part of the solution. This then converts messages that are delivered by the UDP packet forwarder mode on the LoRaWAN gateway into an MQTT message, which can then be processed in our ThingStream platform. From there, we have a tool called our Data Flow Manager, which can receive those messages. You can then work with the payload that was sent to apply different formatting, for example, for different backend systems. And there are then a range of connectors which can send that data through to the enterprise. So if we take a look at the way that looks from an architecture point of view, here on the left-hand side, we have your LoRaWAN things, your LoRaWAN gateway, typically communicating in packet forwarder mode using UDP. These items in dark green are the ones which u-blox provide as part of the MQTT Here service. So the LoRaWAN gateway bridge, which converts that message to MQTT, LoRaWAN network server and application server, which then handle sending that message through to our MQTT broker. And then we have a range of possibilities for getting that data out into the enterprise, whether that's as an HTTP post to a REST API. It could be calling one of a number of perhaps AWS services or dropping that data into Microsoft Azure, a whole range of different ways that data can come out. So the combination of MQTT Here with CloudLocate and the Cicerone board gives a really nice, complete end-to-end power-efficient solution for your tracking needs. So in summary, CloudLocate provides sub 10 meter level accuracy. just from that, a couple of seconds of satellite reading from the device. Gives you full energy autonomy. So the calculation of the position is offloaded to the cloud, so you don't need to keep that GNSS module powered up on the device. The result of that is you can have months or even years of battery life on devices out in the field. The message that you sent is between 12 and 50 bytes, so very, very low bandwidth, perfectly suited for LoRaWAN. And then the addition of MQTT here gives you that fully managed LoRaWAN network server environment, just to make the rollout of LoRaWAN even easier than it would otherwise be. And with that, I will pass back to Elenia, who will just summarize and wrap up on the webinar. Thanks for your attention.
Vedi lo schermo? Ok, mute. Okay, can you see my screen again? I think so. Okay, so we are done for today. Thank you for joining us. If you would like to get in contact with us, you can just write to me. My contact is ilenia.carola@movex.it. I repeat, I'm the business development manager for our IoT division. Then, if you would like to learn more about the company, about Move-X, about our product, you can also visit our website. The website that is movex.it, or our GitHub page. We have a lot of useful content on GitHub. And also you can text to info@movex.it. I will invite you to also follow us on our social media, on Instagram and LinkedIn, and also on our YouTube page. You will find the recording of this webinar, and as well as our previous webinars. So that's all for today. I would like also to say thank you to Nick and Giovanni. Thank you so much, and see you next webinar, and have a great day.
Thank you.
Bye.
Yeah. Thanks. Bye-bye.
Bye-bye. Thank you.